two programs I've worked on. First will be it's a very simple raycaster. Unfortunately, due to time constraints, for lack of a better word, is very unfinished in what I wanted to do. I'll just bring it up. It was an extension of one of the advanced graphics assignments we did in class. So, just provide a very simple scene: spheres, polygons, planes, and cylinders in two different views, orthogonal and perspective, and to add in different features to show how light changes with the ray caster. So as you can see, just in an orthogonal view, everything's pretty straightforward and flat. Adding effects, a fog attenuation, which you can see shades of the lighting isn't the best. I apologise for, but you can see that different objects further away obviously fade out quite considerably into a dense fog. Similarly, just to have a very simple shadow effect on each object to show that each object is placed behind one another. The reason you can see shadows in the background is the entire scene is in front of a solid plane, so you can see these shadows more clearly. And what I onto that is a simple ray reflection. This is a part way of turning it into a ray tracer. So I didn't have the time to implement a transmission through the objects, so I just put in a simple reflection factor into it. As you can see, you bounce off one surface of the object onto the surface of another and add the light colour respectively. And quite simply, just in terms of depth, you can view it as perspective mode. Provides a little bit easier, especially on the polygon space at the front. So they're quite unclear from a orthogonal view. They do have quite a different depth. It's just not working for me now. There we go. As you can see, different objects have different depth, the size varies, even the object's shape varies. There's some purple sphere at the back. It's much further away than the blue one, and on slight angle you can see how it changes just through the view. So that was very simple. I did want to change that into a OpenGL version, into a full ray tracer, but as I said, the time constraints were a problem. The other program I wish to show is a particle system I worked on whilst I was in Canada. This is a design of a group effort from me and two other students when I was studying over there. It's done with C++ using Lua bind and Lua script. There is no user interface. This is a completely scripted particle system. I'll just run a few tests. So you can see there, a very simple particle system. Just a single point source shoots particles, in this case 1,000 particles, into different directions. The colours you can vary from, they can start with a colour, you can have them change into whatever you want. You can change the speed at which the particles accelerate in whatever direction. I'm just going to run through a few different tests we put up together. So that's just a very quick circle of lines, particles floating upwards. It's quite simply a ring effect, shooting particles off afterwards. This is actually was done as a testing mechanism to see how we could possibly optimise the particle system into making it more efficient and better looking. So you can see two rings of fire. The one on the right is clearly more pronounced than the one on the left. This is due to they're using two different parts of the computer. The one on the left is using just a GPU. The one on the right is using a CPU and a graphics card where necessary. So you can see the appearance difference. And as another feature, instead of loading just a straight dots or drawing to a pixel or perhaps a line segment on each of these particles, we added in the feature of being able to display an image. So we load in an image when we run it, and that way we can display a picture of, say, a flame, or in further instances, a cloud. Another very simple one, just a few particles. We have travel in different interpolation types. So there's a quadratic, cubic and spherical interpolation there. So very simple example just to show that particles can be manipulated in different ways. This is, again, a very simple explosion effect. These particles actually, when they get further away, the number of particles there actually increases to allow the size to get bigger. This keeps growing and growing. It can slow down the computer quite considerably after a while. It's hard to tell from a distance, but when you go up a bit closer, okay. Unfortunately, the problem with Lua and scripted, when you try and zoom in, it does it on a rotational basis, so it kind of goes in and out as you go closer to that, so it's a bit difficult to manage. But again, that's just loaded up a very simple blob image into a box, so we confine particles to a certain area on this one. Again, just a different fire effect to see in comparison. Compare the GPU with the CPU. This is just a very simple cloud effect again. Again, we've just confined all particles emitted into a box. In this particular instance, we gave them a longer life, so you won't see them change all that much. This is one of my more favourite examples. It's just a very nice spinning clouds. Here, as I said, you can change the colour and the effect of the particles. This one's a very simple spiral out effect. This is where most of the programming I did on this particular assignment went into, was how the particles can be affected once they are emitted. So we had it initially as just everything came from one point and you gave it a velocity and a direction. After that we decided, no, we'd like to have it confined, so we gave it bounding boxes, bounding spheres. Eventually we gave it particles that they enabled to be given different velocities so they could perform circular motions. This is again iterating the circular motion as well as the expansion of particles. This will continually create, I think, up to about 20,000 or 25,000 particles. It does slow the system down a little bit, but bear in mind the technology that we've actually designed this on is on a newer computer than my laptop is at the moment. But with any modern day